Welcome back to another example video with eigenvalues and eigenvectors. This video will focus on the other quicker method to finding the eigenvectors. It's not necessarily quicker, you're just kind of eyeballing and just kind of guessing. So it can be quick sometimes. I think with enough practice it can be quick. But yeah, we're just gonna go ahead and do this example. I purposely picked another triangular matrix, mostly because I mainly want to focus on the eigenvector part instead of the eigenvalues. So pretty much going straight into this, we already know that the eigenvalues are just everything across the diagonal. So it'll be 2, 3, and 1. And so now when we want to find the eigenvectors, we're just gonna start off with the not the second one, eigenvalue of 2. And so this method, it's kind of like eyeballing it. So it's the same thing. So you find the characteristic equation, or just find the eigenvalues first. And then what we're gonna do now is we're just gonna plug it into our matrix. So we will have 0, 0, 0, then 0, 1, 0, then 1, 4, -1. And so to find our eigenvector, we're just gonna eyeball it. And so what I mean by eyeballing it is you just look at each row and pretty much guess the values, because we know that this is all gonna be equal to 0. So we're gonna find some value in the first column, and then some value at the second column, some value at the third column, and when you add them all together in each row, it will all equal to 0. And so this is kind of like where the guessing part comes in, but you can effectively be like a good guesser just by looking at it, or just doing this repetitively. One of the ways you can do it is if you have your matrix in this form, so that means there is a column of zeros, then that means that column will have a value, which is in most cases 1, and then everything else is going to be 0. So in this case, the first eigenvector will just be 1, 0, 0. Because when you multiply this out, you'll have a 1 times 0 is 0, and then you have 0 plus 0, and then again it's the 1 times 0, which is 0, and then we have the plus 0 plus 0, and the same thing goes. And the reason why this works is because if you let this or either of these two zeros be any other number, then you can't really cancel the other one. So let's say for the, let me use a different color. For the second row, we will have, well, we established that the first one's going to be 1. We're going to have 1 times 0, and then it's going to be plus 1 times some constant plus 4 times some other constant, c2, is equal to 0. We can effectively make c equal to -4 and then c2 equal to 1. But when you go to the third row, you'll have 1 times 0 plus 0 times -4 plus 1 times -1. I wrote this wrong. 1 times -1, and that's not going to be equal to 0. So it doesn't matter what constants you do. The same thing goes if you do it with the third row. It doesn't matter which one you do, it's ultimately gonna, one of them has to be 0. And then it becomes obvious when you just look at the first row. So in the first row, we have 2 free variables, which will be the first and the second one. So this one and this one. And so by default, number 1 has to be 0. And if the third one has to be 0, then that means the second one also has to be 0, because you can't cancel out a 1, or you can't make 1 equal to 0 unless you multiply it by 0. So it's kind of hard to explain, and that's kind of part of the reason why this why I want to make this video is just kind of show like the other method. And if we were to do it like the long way, obviously if we put this in row reduced echelon form, we are going to get the matrix 0 0 0 and then 1 0 0 and then 0 1 0. And so the solution would just be x1 x2 x3. This is the same thing that we did last video, and we're just gonna be 0 1 1, and this is gonna be plus s 1 0 0, and we can see that this is the same thing as the eigenvector that we guessed. Well, some people can argue that I'm just kind of like, I already know this because I did this, but it works with like just any, like, just do it on the spot. It's not that I already memorized this. It's just that that's how I did it. So we're just gonna move on with the next eigenvalue, which is lambda is equal to 3. And so when you put that in, you'll have -1 0 0 0 0 0 1 4 -2. That does not look like a 0. And so our eigenvector will just be, again, we have to guess. We have a column of zeros, so that means that's just going to be 1, and that means everything else is going to be a 0. So that one's another easier one. Again, if you want to verify using the long way, and we put this in row reduced echelon form, we should get 1 0 0 0 0 0 0 1 0. And so our solution just becomes x1 x2 x3 is equal to, we have a 1 here, so it's going to be a 1, and then on the third row as well, or third column, and it's plus s times 0 1 0. And again, it's the same thing as we got when we did our eyeballing guess. And so our last one is going to be when lambda is equal to 1. And so that will give us 0? No, 1 0 0 and then 0 2 0 and then 1 4 0. Then here we have a row of zeros, so that means it's the nullity is going to be 1, its dimension. And so our third eigenvector, or I guess, yeah, the eigenvector corresponding to this lambda will be, this is where it becomes tricky, because we have a row of zeros, and that one by default will have to equal to 1. And then this is where it becomes like the more kind of like guessing and verifying. So we have, use a different color. We have 1 times some constant plus 0 plus, we already determined that this is going to be 1. And that's equal to 0. So that means C is going to equal to -1. So this would be -1. And then now the second one will have -1 times 0 plus 2 times C2 plus 4 times 1. That's going to be equal to 0. So that means C2 is going to be -2. And that's how, that's pretty much how you actually find it. You can do it in paper. You can have it scratch paper, or if you really want to be like cracked and and not do not write this down. You can do it all in your head, and that's only if you feel confident with keeping everything in your head. But yeah, that's pretty much it. If you put this in a reduced echelon form, you'll get 1 0 0 0 1 0 1 2 0, and so our solution will be x1 x2 x3 gonna equal to 1 1 0 plus s times -1 -2 1. And like I said, you look at the kernel, it's going to be the same thing as what we find, and so ultimately our answer is going to be lambda 1 is going to equal to 2 with the vector eigenvector. Is it 1 0 0? I think it was 1 0 0. 1 0 0. 1 0 0. And then second eigenvalue be lambda 2, which is equal to 3, with the corresponding eigenvector equaling to 0 1 0. And then lastly, the third eigenvalue, which is equal to 1, with the corresponding eigenvector being -1 -2 1. And that's pretty much it with this video and this example. Again, it's really up to you on how you want to do it. In terms of like kind of like exams and all that stuff, I kind of recommend trying to learn how to do this one so you can save time. And then in terms of just kind of like everyday thing like homework, feel free to use the other method, but like it's personal preference on how you guys are. And other than that, that's pretty much it for this video. So I will see you in the next one.